So the next talk is by Jonathan Fine, formerly from the Open University. Are you still working there, or are you retired, Jonathan? I can't remember.
Listen to my talk, you'll find out retired.
Well, let's just start your talk.
Thank you for coming to this talk, and thank you, TUG, for organising this conference. I'm most grateful to both of you. This talk is about learning LaTeX. It's about helping beginners. I was a beginner once. In 1989, I bought a copy of the tech book and learned tech. I've 30 years' experience of being a tech user. Since about 1990, I've been a member of a user group. I've been past chair of UK TUG and past board member of TUG. I'm now retired and pursuing my interest in mathematical research. A few words about this talk. I look at 4 websites, all of which offer learning resources. They are 1. Trinket.io, which is loosely associated with the Raspberry Pi Foundation. 2nd, my own LaTeX typing tutor. 3rd, the LaTeX 3 projects learnlatex.org. And finally, math.stackexchange. All of these sites offer learning resources for people who want to learn LaTeX. They do it in different ways, for different purposes at different levels. For me, the important level is the complete beginner, somebody who knows nothing about LaTeX, perhaps except the name, and who wants to do something quite simple, such as put an equation onto a math page. In fact, I'm interested in people who want to post onto math.stackexchange and want a place where they can develop their skills and learn their skills and share things. So what this talk really is about is learning journeys. A learning journey consists of lessons and exercises, and if it's being done through a website, then there's a user interface and a user experience. The interface is programmed, but the experience is a softer thing. It's a question of expectations and those sorts of things. What makes the website pleasant and easy to use. So if you know about these things, 2 important concepts will be user interface, which I've already mentioned, and user experience. They're both important today in web development. So next up, there will be screencasts of the 4 sites. I'll remind you, Trinket.io, LaTeX Typing Tutor, learnlatex.org, math.stackexchange. During these screencasts, I'll speak, but you won't see me. I'll reappear at the end of the talk for a summary.
2 plus 2 equals 4. Notice how the spacing changes. 2 times 3. We've used a control sequence. Fractions. 1/3 plus 1/6 equals 1/2. We get some funny errors. And now we've run out of space. The very first Pythagorean triple, we used caret for superscripts. The sum of the numbers 1 plus 2 plus 3 plus 4, it's a bit long, it only just fits in, look. The sum of the numbers from 1 to 100, C dots for the gap. Gauss did this as a child, doesn't fit in, what a pity. Neither side fits in. The general form of Pythagoras theorem, italicized letters for variables. A special case of Fermat's last theorem. This was known to Fermat, a special control sequence. An integral. The work in progress is a bit noisy as it goes on. We introduce a little bit of extra space to make it look nice. Now we've got there, isn't that lovely? To finish, the recursion that gives the Fibonacci numbers, curly braces and underscore. Again, doesn't that look nice? Notice how the N gets tucked up under the F. What we have here is a LaTeX typing tutor that I produced at the beginning of the year. It's rather different than what we saw before, which was intended by Trinket to allow you to edit 5, 10, 20 lines of code. This is designed for problems that have a single line of code as their answer and usually only involve one or perhaps two concepts. The whole widget is structured as follows. At the top is your target, your goal. In the middle is the rendered version of your answer so far. And in the bottom, I'm afraid it's not very clear, there's a data entry box where you type your answer, and your task is to get your answer to meet the goal. So let's see how it works. We all know 2 + 2 = 4, but let's just see how it works and pay attention to the user experience. What do you see, what are you aware of when the whole thing happens? Okay, one of the things I noticed is that everything's aligned except the third line. The third line should be aligned in the middle so that there's not a visual dissonance, so that it's all close to C. The next part of the interface is that on the tutor you press the enter key to get a new task. So it's very simple. You type until you get the answer or you give up, and then you type enter. And if you're completely flabbergasted, not shown but further down in the page is the answer to the question. So you can always cheat. You can always go to the end of the page to have a look. So there's an interface here that's designed for a purpose, and it's a specialized purpose, which is single line answers to LaTeX typing problems. As tech experts, we know that to get the multiplication sign, we don't type an X, we type backslash times, a control sequence. Otherwise, it's not much difference from 2 + 2 = 4. Let's see how it goes. This one, of course, involves fractions, the \frac frac command. And previously we saw with the Trinket version that we ran out of room. The input is quite long. We won't run out of room this time, and we'll have a bit more focus, I think, on the intermediate stages, the errors that come up when frac doesn't get its arguments. So that's also part of the interface. It's also part of the feedback that the user is getting as to where his formula is. So let's see it go. One of the things I didn't like about the interface is that the first fraction works successfully, and then the failure of the second fraction, because it's incomplete, causes the first fraction to fail. this is a sort of time machine. It was correct before and then suddenly it becomes wrong. I think this is disconcerting, and if we could fix that, that would be great for the user. So we've learned something from this. Well done. This is a Pythagorean triple. It was used by the Egyptians to construct right angles when they were building pyramids. As tech experts, we know that you need to use the circumflex caret character in order to get the superscripts. In the context of a learner who is at high school, you might want to put some of that information in as part of the exercise so that it fits into the rest of their knowledge. How this thing works, there's no surprises. Again, we saw that the missing exponents caused the previous formulas, which were correct, to be wrong. We ought to fix that, I think, if we can. There's nothing new in this example except perhaps the use of the solidus, the /, in order to get the fraction. Notice that everything will fit in the width of the page because we're vertically aligned rather than having two side-by-side panels. Again, nothing special here. I find it quite satisfying to see the formula pass by in front of me as a sort of marquee. From a tech point of view, there's nothing new here except the C dots for the 3 dots. But perhaps you want to have a few words about what that notation means in mathematics, and also a few words about how this formula might be proved, and the fact that Gauss proved it as a young child when it was given to him as a cursed arithmetic problem to keep the children quiet. Nothing special here. Let's see it go. Here we're introducing a new symbol, the not equals to symbol. Everything else is much as before. When a dictionary defines a word, it gives both the definition and one or more examples of the use of the word. Similarly, some students, some people learning LaTeX, would want to learn along with the symbol, the meaning of the symbol, the LaTeX encoding of the symbol, and some uses of the symbol in context. Here we have a special case of Fermat's last theorem, which was, of course, well, perhaps not of course, known to Fermat himself. Let's see it go. This turns out to be another example where the intermediate forms of the formula are a bit complicated and confusing. If we could stabilize it, that would be nice. Let's see it go. Did you notice that the \int gave a \in, the member of set relationship? This formula is a favourite of mine. It's the recursion that gives the Fibonacci numbers. Part of the Fibonacci numbers go 2, 3, 5, 8, which you may recognise as part of my email address. My mathematical work also involves the Fibonacci numbers, so they're a special favourite of mine. Let's see this formula go. Again, we might have some links relating to the Fibonacci numbers and other things, as part of this exercise. Some people might like that, or you might say it's a distraction, it shouldn't be there. That's a matter for whoever's doing the teaching or whoever's setting up the site or whatever. What's right depends on who we're dealing with. There's no one right answer. This last range of examples comes from learnlatex.org, which was created by the LaTeX 3 project. It's got going about 2-3 months after my project, in other words March, April this year. Joseph Wright will be talking later about this at this conference. I look forward to hearing his talk. I'm going to show how it works for a third plus a sixth equals a half. But before I do that, I want to say that this comparison I'm making is rather unfair, because we have different goals. My goal is a LaTeX typing tutor for math formulas that fit in one line, and I'm able to use MathJax. Their goal is to tutor people, to train people in whole document typesetting, which is a completely higher level of sophistication. To my way of thinking, somebody who's ready to start whole document typesetting with LaTeX is not a beginner. They are an intermediate user already, provided they have mastered the mathematical formula part of LaTeX. So the comparison we're about to see, as I said, is a little unfair because it's comparing apples and oranges. They're both good, they're both similar to each other, but they're good in different ways. They have different purposes and they fit into the world in different ways. So I don't see them as competitors. I see them as doing different things. That said, let's see the example. And at this point, it's quite interesting. Nothing happens. There's no automatic online preview. Nothing happens. You have to move your mouse and click on one of these two buttons, Open in Overleaf or LaTeX Online. This is because the rendering process is so expensive that it can only be summoned manually. It will just be chaos if we try to render the formula keystroke by keystroke, as we saw in the earlier examples. This doesn't make it better or worse, it makes it different. And because they're doing whole document typesetting, they have to take some sort of approach like this. Although Jim Carlson's talk on mini LaTeX takes a different approach, which is intermediate between the full LaTeX approach and my single formula approach. So there's the single formula approach, the mini LaTeX approach of Jim Carlson, and the full LaTeX approach of the LaTeX 3 team. So I'm going to move on to how we solve this problem. So to remind you, this is where we got to. We've entered the formula and we have to do something for the compilation to take place. We have to move our mouse or cursor and click on the LaTeX Online button or the Overleaf button. But before we do that, perhaps a few words about thank yous. So the LaTeX Online button was provided by Johan Tornad. Well, not the button, but the service behind the button was provided by Johan Tornad. And the Overleaf button was provided by, well, Overleaf, of course. And we have two talks from Overleaf and a talk from Johan later in this conference. I'm looking to them, all of them. So let's now see what happens if we click the LaTeX Online button, which will send our little document across the internet. A service will compile it for us and return it to us, and our browser will display the resulting PDF. It will be a PDF we get. So let's see what happens. Well, it's come back quite quickly, not instantaneously, a second or two. A lot will depend upon, well, the internet really. But where's the formula? Well, this is interesting because the formula is actually off screen. It's further down. Because this project is aimed at whole page, whole document typesetting, it wants to display a whole page of typeset material, whereas all we're providing is one formula. So, as I said, this is an unfair comparison. The LaTeX typing tutor is aiming to do one thing. The Trinket.io tool is aiming to do something quite similar. And Jim Carlson's mini LaTeX is somewhere between the one end and the other. This is a very important page. It was created by users of MathJax Exchange to record and share their use of LaTeX. By the way, MathJax is a LaTeX interpreter for web pages. This page is full of extremely valuable resources. It could be the basis for a widely used and useful help system for LaTeX. And if it was added to interactive examples, so you could take the examples and modify them to give you what you want, that would be really very helpful indeed, and would make LaTeX very much more helpful and attractive, I think, to new users. Let me go through this page fairly quickly so we can see what there is here. Well, the first thing is it has been viewed 1.1 million times. It's a very important page. It has an enormous number of credits and it's an active page. This is one of the most important pages on mathematics.stackexchange. Here we've got Greek letters, superscripts, subscripts, grouping, which we've seen before. And do you see this sort of stuff? It would be nice to have it interactive, the way in which braces interact with superscripts. We've got parentheses of various sizes, sums and integrals, fonts, fractions, we did fractions, radicals, lots of fonts, special functions, special symbols, currently supported LaTeX commands, accents and diacriticals. And then here we've got a list, an alphabetical list of contents of MathJax titles by MathJax topics by title. So look at this. Isn't this something? Well, this is the conclusion. Thank you for bearing with me. We've been on a journey entirely browser based, going from quite simple things like 2 + 2 = 4 and fractions and that sort of stuff, all the way to some quite complicated and deep mathematics. And it's all browser based, using LaTeX markup and MathJax typesetting. It'll even work on your mobile phone. I've tried it. And nothing to install, and always the latest version of the software. Lots of advantages. I'm not saying there aren't disadvantages, but let's take what we can. So I find the situation promising and encouraging. There's a chance for new life here. And here are 3 examples of why I'm encouraged. Well, Trinket, which is widely used, supports HTML, CSS, JavaScript and Python. And I thought, wouldn't it be nice if they supported LaTeX as well? So I wrote to them in June, suggesting that they do just that, and talking about my experiments, and we had a nice conversation. But the thing is, they replied and said, we've already got an experimental implementation. I don't know where it'll go, but if we encourage them, and if there's a real benefit in they're doing it, perhaps they'll do it. So that's a real target. If we can get LaTeX
as an equal or a peer of JavaScript and Python in the schools, so that it's just as easy for teachers to deal with LaTeX as it is with Python, then wouldn't that be a big plus? The second is Jim Carson's Mini LaTeX, which he's talking about later in this conference, which deals with whole documents and generates PDF via LaTeX. So we're seeing the beginnings of a bridge that goes from very simple browser-based stuff all the way through to the big documents. And if that bridge works well, won't it be wonderful? Wouldn't it be wonderful if the experience we had on the web page and the experience we had on print were in some sense closely linked? Now, the third thing that I find promising is that Math.StackExchange has a thriving community of MathJax users, and they're already producing good online documentation about the system. I was very surprised to find that, and very, very pleased. And I think one of my first steps after this conference will actually be to contact some of those people and ask what they think about things, and can we work together perhaps. So I find the whole thing quite promising. And here's something else I find quite promising, which is actually looking for LaTeX where you expect to find it, which is what I did with Trinket. And when it's not there, or when it is there, getting in touch with people. There's a lot that can be done in that way, just making connections. So I'm going to see what we can do in that way, and perhaps we can join the MathStackExchange community or form a community of our own. But this whole idea of being able to use LaTeX in an entirely browser-based way is, I think, very, very attractive. Now, many people are using LaTeX and MathJax as part of other software systems. I'm thinking particularly of Jupyter notebooks. There are others, but I won't list them here. Let's spend more time with all these people who are using tech along with other tools and see what we can do to improve their tech experience. Often they're using tech as a back-end system, which we're going to hear about several times in this conference. Who knows? We might learn something from them. Finally, I'd like to thank you for listening to my talk and persevering to the end. And I'd like to thank the Tech Users Group and the people who have been running this conference for putting all the effort in and making it work. And finally, I'd like to thank Don Knuth, who devoted several years of his life to producing one of the finest pieces of software I know. And he has originated the community. We should be celebrating and experience gratitude for what's happened before. So, have a good conference. Thank you for listening to my talk and keep safe. Goodbye.
Hello, everybody. So Jonathan asks me, what do you want, Jonathan?
I want you to tell everybody, as chair, that the question and answer session will be starting soon. And then I want you to start the question and answer session. And then I'll take over.
Well, you're already on, so please do so. You've all heard Jonathan.
Thank you. So are there any questions? So I've got one already from Hugh, which was, well, the question was along the lines of, you can't assume that somebody learning LaTeX has already understood LaTeX mathematics. And I think that's correct. I was a bit math-centric there. I tend to think that everybody in the world is a mathematician because I'm a mathematician. but it doesn't work in that setting. But I would expect something like Jim Carlson's mini LaTeX, which he's talking about tomorrow, will provide a similar role to the Trinket application, that you learn LaTeX in the simplest environment you can. LaTeX is a markup language as well as a tool for typesetting. And if we can learn the markup language in a nice environment, then that's good. So I accept half the criticism, and Jim Carlson deals with the rest. Is there another question? Did you all get that? Hello, are there any questions? Or am I talking without an audience?
Jonathan, the attendants can't talk. They can only write in the chat. It's only the panelists who can speak. So you need to watch. There are two different channels for writing chat messages.
Okay, so
So it seems it's like Jonathan has left. It seems like Jonathan has left. I can't see him in the list of participants. That is a little strange. Let's give him a few minutes. Every one of the speakers who come next have agreed to postpone their talks by 20 minutes. So that means that Joseph Wright will be speaking in, will be starting in 10 minutes. So Jonathan's back. Hello again. You had connection problems, I understand. There has been a question in the meantime. Can you see it? It's by Tristan Miller.
Sorry, I've got the question. We've learned LaTeX from printing books rather than online. There's actually a third media. There's online HTML web pages, there's printed books, and then there's PDF on screen. Now, I think that printed materials do have an importance, and that we have to, so to speak, compromise. If we're uncompromising HTML, then we're sacrificing a lot. And similarly, if we're uncompromisingly PDF, we're sacrificing a lot. The main thing I like about print is the discipline and tradition associated with it. So, for example, there's an archival quality to print. That was one of the big benefits when it was introduced, was there was an archival quality to it. The printed documents were preserved. There's also the question of high quality. So a high quality document is always valuable, but it takes time. A timely document is also always valuable. So I'm all in favor of permanence being available and quality being available. And I'm also very much in favor of accessibility, which means producing things in the appropriate medium. And the appropriate medium might depend upon the circumstances. So a book can be useful in some circumstances and a nuisance in another, and similarly for a web page. So I'm more or less in the Pandoc school, I think, of write good content and render it well as is needed. So does that answer the question from Tom? Oh, sorry, this is a question that Tom asked me privately, so you didn't all see it. But yes, I think I've answered that question. Tom, has that answered my question?
Well, I just repeated the question you got from Tristan because I wasn't sure that you see it. So it's the same question. Sorry for confusion.
Thanks, Tristan. There's time for another question, I think, if we want one. Perhaps I'll conclude. I'm really pleased that we overcome all the problems, that that it's always useful to have a plan B, and that I'm pleased that you got the whole talk, even if it was in a bit of the wrong order. It's a bit like a meal at some restaurants, perhaps, although I haven't been to a restaurant for a bit. And I'm delighted to have been able to give this talk. I'm delighted that TUG has made this conference online and that so many people are attending it. I'm looking forward to the future talks. So this is the end for me as a presenter, except to say that I'm talking again tomorrow. So if you have any questions, catch me tomorrow or catch me on the Zulip channel. So I'm going to say goodbye as a presenter. Goodbye.